Okay, welcome to this lesson with Teacher Kamanga in physics. In today's lesson, we want to look at measurements. So, in short, when we look at physics, physics is a study of measurements. Or, in short, we can just say a science of measurements. Because whatever we do in physics, we need to measure. Whatever calculations we need to have, we need to measure those calculations. So, there are some instruments that are used in order to get the measurements. So, for example, we're talking about the meter law, we're talking about a micrometer screw gauge, we're talking about the vernier calipers. Yeah, so all those are examples of instruments that we can use in order to measure length of different objects. Now, there are small objects that are difficult to measure if we're using big object, like we're talking about a meter rule. A meter rule, mostly we know for sure that it's very long. We cannot use to measure the diameter of small objects. So there are other instruments that are used in this case. Now, in today's lesson, we want to look at two instruments that are very important in physics, and these are the vernier calipers and also the micrometer screw gauge. Now, what we are seeing on our screen there, this is what we call a vernier calipers instrument. So, this instrument, it is very important because it is used to measure the internal and also external diameter of hollow objects. So we have objects that are, for example, if we're talking about a pipe that is used maybe to transport water, this one can easily measure its diameter. All right. Now, what we need to understand is that this particular instrument, it has parts. For instance, here we have what we call the internal joule. The internal joules are the ones that measure the internal diameter of a hollow object. Then also we have the external joules there. The external joules, they're the ones that measure the external diameter of an object. Then also it has two scales. We have the main scale, which is this one, and also we have the vernier scale, which is this one. The vernier scale, in most cases, it is the one that rotates. Okay, we need to understand. Then at the end there, we have what we call a stem. In some other cases, this is used to measure the depth of some other objects. Okay, so we need to understand that. Now, when you look at the vernier scale and also the main scale, these scales are very important because from there, this is where we are able to get the readings if at all we want to measure. Now, what we need to understand is that always the number that we get from the vernier scale, it must be able to be multiplied to the accuracy of the vernier caliper. So the accuracy of the vernier caliper, it's 1/10 millimeters, or if you like, you can say 0.1 millimeters. So these accuracies are very important in our calculations because we're going to be using them. So we need to understand and also be able to remember them as when we are trying to calculate. Okay, there are some times when you are given these calculations, you look at the number of divisions, then also you realize that the number of divisions sometimes they can be different. Sometimes they can put the divisions by 2, sometimes it can be an individual division, sometimes it can be 0.5. So we're also going to look at that so that we understand. There are some very serious precautions that we should be able to take as we are able to use this instrument. So the first precautions that we should be able to take is number one, we need to zero the instrument. We need to make sure that the reading that we are going to be taking, we are starting from 0. That's what it means to zero the instrument. Number two, we also need to clean the instrument so that it can be free of particles, because if the particles are there in the joules, those particles, as we are taking the readings, we can still be able to account for them. So this is why we're saying that the two precautions: number one, you clear the instrument; number two, we also need to zero the instrument so that we take the readings before the zero. So there are some procedures that we're going to do as we are trying to take the reading with this particular instrument. So number one, we need to find the value on the main scale that appears just before the zero of the vernier scale in the centimeters. And also the other one is that we need to find the value of the line on the vernier scale that coincides with the line on the main scale and multiply it by 0.01 centimeters. So remember what I said. I said 1/10, that is in millimeters. Then in centimeters, it's 1/100. So this, when you try to convert it, you are going to get 1/100. when you say you divide by 1, you're going to have 0.01. So this is what we're going to be using in centimeters when we are able to calculate. Now, some questions they can ask you to calculate in millimeters. So if you're calculating in milliliters, you use 1/10. But if you're not told, or it is not specified to say to the units where you're going to be able to use to calculate your answer, please always use centimeters. So 1/100, that is what we're going to be using if at all the question does not specify the units. Okay, this is very, very important. All right, now we have the example there that we have. So from this example, we want to see how can we get the reading. So now this, what we are seeing here, this on top there is what we call the main scale. So on top, that's where the main scale is. Then down here, this is where we have the vernier scale. Okay, so now how do you get the readings? You get the readings starting from the main scale. You get the readings starting from the main scale. Now, on the main scale also, it is very important to understand that we do not just get any reading, but we look at the last digit before the vernier scale starts. The last digit before the vernier scale starts. So the last digit before the vernier scale starts, when you look at down there, you have the 0. So you get the last digit before the vernier scale starts, which is just there above the 0. So this is what we need to know. So this one above the 0, how do we know that, okay, this value, it is this? What will guide you is when you look at here, we have the 4 and there we have the 5. So we look at how many divisions do we have in between 4 and 5. So how many divisions do we have between 4 and 5? So we have 4, then there we have 1, 2, 3, 4, 5 there, then we have 6, 7, 8, 9, 10. So this means that each particular division is a 0.1. So if we have 4 there, we have 4.1, 4.2, 4.3, 4.4, 4.5, 4.6, 4.7, 4.8, 4.9, then we have 5. Okay, so when you look at that one, the digit just before the 0 on top there it is 4.5. So the 4.5 is the one that we're going to get. So remember, the 4.5 is the one that we're going to get because that is the last digit. Now, after getting that one, you need to come to the vernier scale. So the vernier scale is down there. So on the vernier scale, there is only one justification of a point that you're going to pick. You need to pick a point which it is going to coincide from the main scale and also the vernier scale. So you are going to look for a line where, if for instance this is a vernier scale, this is a vernier caliper, then on top here it's a main scale and down there it's a vernier scale. So you look for a line that crosses like this. So the number that is there is the one that you're going to get. Okay, so let's come to our diagram and locate that particular line. So you're going to realize that when you look at 5 is just direct like that, straight. But when you look at these other divisions, they're able to miss each other. So we're going to get 5, right? So the 5, we get it like that. So this 5 is the one that we have said you're going to multiply it with the accuracy, which is in centimeters. So say 5 times 1/100. Okay, 5 times 1/100. So 5 times 1/100, you're going to realize that when you multiply this, you're going to have 0.05. So this 0.05 is the one that you're going to add it to the 4.5 so that you have your answer. So our answer in this case, when you are able to calculate, you will realize that it will be 4.55 centimeters. So 4.55 centimeters is going to be our answer. Okay, so we can be able to see that this calculation that we are just trying to do, this is also what they did here. So that is our answer. So it's very, very important that we understand how we're supposed to get these readings. Okay, let's look at another example. So our other example, it is example number 2. We are saying state the reading shown in the diagram of the vernier calipers below. State the readings shown on the vernier calipers below. So what we're going to do is the same procedure that we're going to do. Number 1, you look at the last digit that you're going to get. So the last digit should be the one before the vernier scale starts. So I've said the vernier scale is the one that is down there, then the main scale is the one that is on the top. So we're going to look at which one is the last digit just before the vernier scale starts. So you'll realize that after the 0 on top, there is 1 there, 1 division, then there's a 0. So this 1 division is the one that we're going to get. So the 1 division there is the one that we're going to get. So meaning that, for instance, we have 0 there. So from 0 there up to 1, where there is 1 there, on top where there is 1 there, we're able to see that we have about 10 divisions. So meaning that each division is 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, 0 0.6, 0 0.7, 0 0.8, 0 0.9, then we have 1 which is there now. Okay, so we're able to see that the one that we have found there, it is 0 0.1. So the 0 0.1 is the one that we're going to get on the main scale. Then from there, we're going to come now down there on the vernier scale. The vernier scale, remember what we did on the first one, we are locating a line which is coinciding the main scale and also the vernier scale. Is the one that we are going to get. So you follow it through there so that you are able to check down there which line coincides with the main scale and also the vernier scale. So when you check nicely there, you're going to realize that here, just before the 4th division there, on down there, you're able to see that it's crossing. Just before there we have 5, then we have that 4 division, then we have the 3 division which is coinciding from the main scale to the vernier scale, which is just coming direct like that. All right. So when we get to these 3 that we are going to see, because we have noticed that that is the 3 which is coinciding to the main scale and also the vernier scale. So the 3 that we are going to get, we'll get the 3. Now we said these 3 that we get from the vernier scale, they were supposed to multiply it with the accuracy, which is 1 over 100. So this 1 over 100, when you multiply with the 3, you're going to have 0 0.03. So the 0.03 is the one that you're going to add now to the one that we had already found on top there. Remember that we had found that it's 0.1 on top. So the 0.1 plus 0.03. So 0.1 plus 0.03. So when you add this, you're going to have 0.13 in centimeters. So this is going to be our answer. And for sure, this is also what we are trying to see from our answer there. As we are trying to prove, we are able to see that these are the calculations which were also done like that. So what is important is that we should be able to know how we should be able to identify these values so that it becomes easy for us to be able to solve a question that can be asked in this manner. Okay, so this is an explanation on the vernier calipers. So I'll take you through the questions so that you still be able to see how questions might be able to come in an exam. All right, so it has been Teacher Kamanga with you in this lesson. Have a good evening.